Hello guys, in this video I'm gonna show you what is the power rule and how we can use power rule to find derivative of the expressions in the form of x to the power of n. In this expression, x is our variable and n is the constant. N can be any real number. To find the derivative of x to the power of n, we bring the power n to the front of the term and we subtract the power by 1. So, derivative of x to the power of n is n x to the n minus 1. For example, derivative of x to the fourth is 4x to the power of 4 minus 1. We bring the power 4 to the front of the term and we subtract the power by 1. We reduce power by 1. So derivative of x to the fourth becomes 4x to the third. Note that 4 minus 1 is 3. Another example. What is the derivative of the expression x to the 2? We bring the power 2 to the front of the x and we subtract the power by 1. 2 minus 1 is 1, so the derivative of x to the 2 is 2x. Note that the power n can be any real number. It can be positive, negative, fraction, and any other number. Let me show you an example with a negative power. For example, x to the negative 3. Derivative of x to the negative 3 is negative 3. X to the negative 3 minus 1. Minus 3 minus 1 is minus 4. And so, the derivative of x to the negative 3 is negative 3 x to the negative 4. Let me show you an example with a fraction power like x to the 2/3. To find the derivative of x to the 2/3, we bring the power 2/3 to the front of the term. So, we have 2/3 x to the 2/3 minus 1. To simplify 2/3 minus 1, we have to do a simple common denominator. 2 over 3 minus 3 over 3. The denominator now are the same. We subtract numerators. 2 minus 3 is minus 1. So we can write our derivative as 2/3 x to the negative 1 over 3. So derivative of the expression x to the 2 over 3 is 2 over 3 x to the negative 1 over 3. Suppose f of x is 1 over x to the power of 2. To find the derivative of 1 over x to the 2, we cannot use power rule right away because x to the 2 is in denominator. And in the power rule, x or variable should be in numerator. We have to have x with a power, not a fraction in this form. But we can rewrite 1 over x2 in the form of x to the negative 2. Now we can use power rule to find the derivative of f of x. So, in this example, first, we converted our fraction 1 over x to the 2 in the form of power 4 x to the negative 2, and then we can use power rule to find the derivative of this function. Based on the power rule, derivative of x to the negative 2 is negative 2 x to the negative 2 minus 1, which is negative 2 x to the negative 3. So derivative of the function f of x equals 1 over x2 is negative 2 x to the negative 3. But if you like, you can rewrite this answer in the fraction form again. X to the negative 3 is actually 1 over x to the 3. So negative 2 x to the negative 3 is negative 2 over x to the 3. We bring the expression x to the negative 3 in the denominator, and so the power negative becomes positive. Another example. Consider this function g of x equals to square root of x. At first, maybe it seems we cannot use power rule to find the derivative of this function. But note that square root of x can be rewritten in the power form, in the form of x to the power of 1 over 2. This 1 in the power is because in the square root x is raised to the power of 1 and the radical index here is 2. So square root of x can be rewritten in the form of x to the 1 over 2. And now we can use power rule to find the derivative of this expression. G prime of x, or derivative of this function based on the power rule, is 1 over 2 x to the 1 over 2 minus 1. To simplify 1 over 2 minus 1, we do a common denominator. 1 over 2 minus 2 over 2 is minus 1 over 2. So the derivative is 1 over 2 x to the negative 1 over 2. And so the derivative of square root of x is 1 over 2 x to the negative 1 over 2. But it's usually better to rewrite your answer again in the radical form. X to the 1 over 2 is actually a square root of x. So x to the negative 1 over 2, because the power is negative, is actually, we rewrite 1 over 2 and we multiply it by 1 over a square root of x. The reason that x to the negative 1 over 2 can be rewritten in the form of 1 over a square root of x is because x to the 1 over 2 here is actually a square root of x. So x to the negative 1 over 2, because the power is negative, means 1 over a square root of x. And now if we multiply top by top and the bottom by bottom, we can rewrite this answer in the form of 1 over 2 square root of x. Let me summarize this example. The derivative of square root of x is 1 over 2 square root of x. I highly recommend you to memorize the derivative of square root of x in the form of 1 over 2 square root of x. In this way, you can get rid of this calculation again and again. If you don't like to memorize this shortcut, always you can write square root of x in the form of power form, x to the 1 over 2, and then use power rule to find the derivative of this function. Now look at this example. F of t equals to 1 over cube root of t. Again, to find the derivative of this function, first we have to write it in the power form. Note that cube root of t is actually t to the 1 over 3, because the power of t is here. When we don't have any power on top of a variable, it's actually 1. So cube root of t is t to the 1/3. But this cube root is in denominator, and to bring t to the 1/3 or cube root of t to the top, we have to make the power negative. So 1 over cube root of t is actually t to the power of negative 1 over 3. And now, because our function or expression is in the power form, we can apply power rule to find the derivative of f of t. F prime of t, derivative of f of t, we show it with f prime of t, is negative 1 over 3. We bring the power to the front of the term and we subtract the power by 1. To simplify the power, we make the denominators the same. Minus 1 minus 3 is minus 4. So the answer is negative 1/3 t to the negative 4/3. Again, it's a good idea to write your answer in the radical form. But if you don't like to do the more calculation, you can leave your answer in this format. But let me show you how you can convert your answer in the radical form again. First, note that t to the 4/3 is actually t to the 4 with a cube root. But because here the power is negative, so we have to write cube root of t to the 4 in denominator. So we have negative 1/3 times by 1 over cube root of t to the 4. We multiply numerator by numerator and denominator by denominator, top by top, bottom by bottom. And so the answer is negative 1 over 3 cube root of t to the 4th. So derivative of the expression 1 over cube root of t is negative 1 over 3 cube root of t to the 4th. Now look at this example. G of r equals to r to the radical 3. At first, this example maybe seems a bit odd, but actually it's a very simple example. To find the derivative of this expression, we can apply power rule because the base r is a variable and the power is a number. Radical 3 is just a number. And so we can use power rule to find the derivative of this function. G prime of r equals to, bring the power down to the front of the term and then subtract the power by 1. Note that here we cannot simplify the power. We cannot simplify the expression radical 3 minus 1 like our previous examples. So we'll leave our answer in this format. Let me review this example again. We had a function with variable r because when we say g of r, the variable of the function is r. When we say f of x, the variable of the function is x. When we say f of t, the variable is t. Here r is the variable and the power is a number. So we can use power rule to find the derivative of r to the radical 3. We bring the power radical 3 to the front of the term and we subtract the power by 1. Look at this example. H of t equals to t to the power of pi. Note that here t is the variable of the function and pi is the power of the t. And because pi is a constant, we can use power rule to find the derivative of t to the pi. H prime of t, derivative of the function h of t, is h prime of t equals to pi t to the pi minus 1. For this particular example, sometimes students ask me that is it necessary that we replace pi with 3.14? No, actually note that pi is not really 3.14. Pi is an irrational number. An approximate value of the pi is 3.14. So don't replace pi in these examples, in examples like this, with 3.14 and leave your answer in this format. So derivative of t to the pi is pi t to the pi minus 1. That's it. Another example. What is the derivative of s of q equals to q to the power of 2.4? In this example, q is our variable and the power is 2.4. Based on the power rule, s prime of q equals to 2.4 q to the power of 2.4 minus 1. 2.4 minus 1 is 1.4, so the answer is 2.4 q to the power of 1.4. Now look at this example. F of u equals to 1 over 5th root of u to the 7. To find the derivative of this function, again, first we have to rewrite the expression 1 over 5th root of u to the 7 in the power form. We can rewrite it as u to the negative 7 over 5. The reason that we put negative in the power is that we bring the expression from denominator to the top, so we have to put a negative in the power. The 7 is because of u is raised to the 7, and the 5 here in denominator is because the index of radical is 5. So 1 over 5th root of u to the 7 is u to the negative 7 over 5. And so now we can use power rule. We bring the power down and then we subtract the power by 1. If you simplify the power, it's actually negative 12 over 5. And finally, if you rewrite your answer again in the radical format as the original function f of u, derivative of the function f of u or f prime of u is actually negative 7 over 5 5th root of u to the 12. And as our last example, look at this function. S of r equals to 1 over r raised to the power of 2019. To find the derivative of this function, first we bring r to the 2019 to the numerator and we write this function in the form of r to the negative 2019. Now by applying power rule, s prime of r equals to negative 2019 r to the negative 2019 minus 1 is negative 2020. One of the common mistakes that I've seen between students is that when they want to subtract the power by 1, instead of subtracting the power by 1, they add to the power instead of subtracting. And they think the power becomes negative 2018, but it's actually negative 2020. Negative 2019 minus 1 is negative 2020. So be careful about this. And finally, because the power of r is negative, it's a good idea to bring r again back to the denominator. So s prime of r is negative 2019 all over r to the 2020. We bring r to the negative 2020 to the denominator, and so the power becomes positive. I hope you enjoyed this video. See you in the next video.